Hello, everyone. Welcome to DevDojo. I'm Rhomel, and we'll be talking about experiments and feature flags today. Here's today's agenda. For the first part, we're going to focus on experimentation. And then the second part, we're going to go switch gears and go to feature flags, though most of this presentation will be on experimentation. And then finally, we'll end with a hands-on session. So the goals for today are to give you a good background or a good foundation on experimentation and an overview of experimentation and feature flags. So I cannot guarantee that everyone here will be an expert, but at least I can point you in the right direction. And that's my hope, that you'll have a good sense and intuition after this on how to approach experimentation and how to use feature flags. So let's start with experimentation. Raise your hand if you have heard of experimentation or know about running experiments. Okay, there's the hands coming in. Unfortunately, not everyone, but that's fine. That's totally fine. Now, how about raise your hand if you have heard of any of these terms? Okay, a few hands again. Well, if you're totally confused, that's totally fine. That's why we're going to have this presentation. And the good news is that we're not going to go into any of these technical terms in depth. We might touch upon some of these terms, but again, as I stated, the goal is here just to give you an intuition about experimentation and how it'll affect you as an engineer at Mercari. So let's start at the very beginning. So this is a very common and very old known experiment. I have to say quote experiment because it's not well documented, but when it comes to physics, there was a point in history where people did not know about the laws of physics, and very basic ones at that how gravity works. And it was only through an experiment that this was proven. So if we take a look here, we have this classic experiment with Galileo, where he apparently dropped two objects from this leaning tower of Pisa, and was able to prove that all objects fall at the same rate, or accelerate at the same rate as they fall. And this was counterintuitive because obviously if you have something very light like a feather, it did not follow this property. So the key here, the key takeaway is that at one point we did not have this knowledge, and through an experiment we now do. So how does this apply to Mercari? Well, here's a concrete example of something we've done in the past at Mercari. We ran an experiment where we have this personal inventory page in the app, and this shows you items that you have previously purchased, and it's a way for you to easily resell these items if you want. Well, on this page, we actually show the prices for these items, and the experiment setup was very simple. We will hide the prices and see what happens. Note that there are two areas where the prices are listed. There's one for the total inventory amount that you have, and then each individual item. Both we tried hiding just the total price, and we also tried hiding both the total price and each individual item price. So, what do you think? Was there any change in behavior I guess raise your hand if you think there was a change in behavior. Just don't raise your hand if you don't think there are any changes. No hands. So everyone thinks, oh, there's one hand. So one person thinks that there was a change in behavior. Everyone else thinks there's no change. Well, actually, the result was there was a change. I have a question here. Why is that it? And I won't answer that today, but that's something to think about. So now that we go back, let's summarize. So here's the basic scientific method. You have a hypothesis, and then you want to test if your hypothesis is true or not. And you can do that with a randomized control experiment. And then you can analyze results and learn from your observations. So you can prove or disprove your hypothesis. That's what the books will tell you, and I will leave it at that for now. So now a quiz. Now that I've given you the very basics, now it's time to test your critical thinking. Which of these answers is the most correct? And here are your options. A way to increase GMV. So why do we run experiments? First answer could be it's a way for us to increase GMV and therefore Mercari's stock price. Another option is it's an empirical method of acquiring knowledge. Another one, maybe establish a data-driven culture that informs rather than relies on the hippo. And the hippo here means the highest paid person's opinion. And the last option I'll give you is compare variations on the same web page to determine which will generate the best outcomes. So maybe in the chat, write your answer, what you think is the right answer. I'll give you a minute. We have multiple selections. All of them. Surprisingly, no one has chosen the first option. Okay, well, I'll assume the rest of you are confused or too scared to choose something. So we'll give you some hints. So here are the references for each answer. The first one is me, so I guess no one trusts me. And the second one is a direct quote from Wikipedia, a well-known source that probably should not be quoted. And the third one is from an actual published book called Trustworthy Online Controlled Experiments by Ron Kohavi, who is a lead on experimentation at Microsoft, as well as other well-known industry experts. And the last one is from the Nielsen Norman User Research Group. They regularly publish like UX related research topics. And this is what they talk about when it comes to A/B testing. So now I'll give you a chance to revise your answer. And if you're still confused, be confident and guess. Now everyone's really quiet. I like the confidence. A lot of people want to say everyone, all of the answers. Okay, so let's move on. This was just uh, something I made up. But for today's discussion, uh, my thesis is that actually number two is the best answer here, and I'll go into why that is. Um, wait, before I go there. So maybe to at a high level, let me preface what we'll discuss. So, why is the first answer not that good of an answer? Well, at any company, you may have internal metrics, and Mercari is no different. And one key metric you may hear a lot about is called GMV. And while this is directly correlated with our stock price, this is not our goal with experimentation. It's a result. Um, so we'll get into what our goal with experimentation actually is. Now let's skip to number three. Why is this one not that good of an answer, even though it's from perhaps the best experts in the industry? Um, well, if we go back to what I was discussing about number one, answer number one is that uh, you don't just want to follow like the hippo, of course. You don't want to follow like your boss. Everyone knows that, and that's an easy kind of, I don't know, argument you can make. But um, what about this part about data-driven culture? Yes, that is also an effect of experimentation. So um, we're here to like learn something. We're not here to like just uh, look at data all day. What's the purpose of looking at the data, really? Um, and finally, the last option is when it comes to UX research. UX researchers often are really focused on these outcomes, trying to find what works best. And again, this is like a behavior that's a result of experimentation. It's not the actual reason why you're doing experimentation. So let's go on. So here is my argument. You will have the scientific method at your fingertips, and when you apply it correctly, then you will learn from your observations. And by learning and discovering some useful properties about how the world really works, you will be able to actually improve the product. In this case, your product will be Mercari. And finally, that will result in the effects that you want, like increased GMV. So this is what we're going to study today, which is we're not looking at correlations. We're looking to find or discover causality. But why not correlations? Um, here's one correlation. So apparently, the more cheese that's consumed, the more the people die from being tangled in their bed sheets. And this is actual data. It's not made up. Um, so there are spurious correlations everywhere. Here's maybe a more tangible correlation. This is made up data, so but this is not far from the truth. So as purchases increase, so do app crashes. I'll give you a moment to maybe ponder why that is. And maybe if there's a brave soul that wants to suggest something in chat, I'll give you a minute to type it in. We have more people, more crashes. Any other ideas? So let's suppose that this data is normalized per user. So on that, the number of users doesn't affect this correlation. Do you have any other ideas given that fact? So the room's pretty silent, so let me help you out. So where did I get this idea, and why did I make this up? Oh, here's a response. So if we have a sale or something of the sort, time limited, you can stress our services and thus cause more crashes. Close, close. So this is actually quite a common correlation in many online services. And it's not specific to ours. Um, but as so here we have purchases and here we have crashes. So as people spend more time on the app, the likelihood of the app crashing as they use it becomes higher as well. So that's something to think about. Uh, so let's take a look at another way of how we're going to run experiments. This is very technical. So I'm going to try a different explanation today. Um, so first, let me just describe to you what's being shown here. So we have some uh, so we want to establish causality, and if you were to be a computer programmer and you had a bug in your program, it's very easy to identify what caused that bug because computers are very deterministic, right? You would try to find the root cause, and once you've identified the root cause, you would rerun your test case and see if it repeats itself. And if the failure happens again, then you know there's a direct uh, causality between what caused your bug and what is causing your program to crash. I mean, and what I'm mixing up my words, but so you identify the root cause of the crash, and so that's that question mark here. The problem with experimentation and with people in general is that we cannot go back in time and rerun. We can't ask people to crash over and over again, right? So we can't just keep giving them medicines and treatments and then seeing what's going to happen over and over again. Uh, this doesn't work in the real world, and I guess medicine is one example, but this also applies to even simple services like uh, you're all using Google Meet right now. And what if we were to experiment with Google Meet? Well, the first time you see a new feature in Google Meet, a new button, you're not going to unsee it. So you can't go back in time and ask the same person to imagine what they would feel like if they had not seen that button. That's the counterfactual. We cannot know that. So what we can do in place of that is gather enough statistical evidence via randomized control trials uh, to identify this if this effect truly holds. So we apply some treatment and then we notice some effect B. Uh, so that's the I guess details, but don't take my word for it. We can look towards what other companies are doing in the tech space. So this is from Netflix. They are also readily applying experimentation. And the key quote I want to pull from this is that the second part. When our members vote down new product experience with their actions, we still learn a lot about their preferences, what works, and then in quote and parentheses, and does not work. So actually, in parentheses, what does not work is also equally important. Uh, if you remember at the beginning of this, I said that we're here when we run experiments in order to learn something. So the worst outcome you could have after you run an experiment is nothing changes. Uh, if if you run an experiment and your metrics go up in a positive way, this is great because obviously you benefit from having found some effect that results in a positive effect. But the opposite is also true. Uh, the metrics could be negatively affected. And I would argue that this is actually equally as valuable because you have found some effect. So if you structured your experiment correctly, you would be able to use this new knowledge to perhaps try and explore more about why that effect is occurring. So if we go back to the personal inventory example I gave, um, even if the answer was that our sellers were less likely to list their items on Mercari when we hid the prices, this would be a very important signal because it would identify that the prices have meaning on this page. So this is something you can think about in your teams. So something which is very important, but we're not quite there yet on is experiment design. I hope that we can get to this point, but each experiment should have a design document associated with it. And it should have all of these key points. Since everyone here is an engineer, we're not going to spend a lot of time about this, but this is just a reference that this is where we're heading. So here's an assignment you can follow up on this personal inventory experiment because it has an example design document that you can look into later. So now let's move on to implementing experience. So since everyone's an engineer here, this is our focus. So the experimentation life cycle as an engineer, here's how you'll be affected. Normally, someone else on your team, usually a PM, will probably be responsible for the pieces surrounding the experiment design and whatnot. So those are the blue squares. And then engineers will probably be brought in. Actually, I said something wrong. So the color doesn't have that meaning. So you'll be involved in any development related square. So for example, implementing the treatments or the variants or the experiments, releasing the app. And then during the experimentation period, you may be asked to help like configure the experiments, configure like the flags and whatnot. And after that, you'll probably most likely be involved with the cleanup of the code or release of the code, and also archiving the old treatments as they exist in the code base, or making them the default experiences. But this is just a map to see what's going to happen, and this will occur over several weeks throughout each quarter. Our current system is quite simple. note that there's a V1 distinction. We're in the process of getting to V2. I'll get to that later. But it's our current system is very basic, where you basically create your own configuration for each experiment or feature flag, and then publish it directly to the system, and then it will your changes will be made in real time. And this is not a mistake. It's published to both production and development. We'll get more into why that is later. We'll look at the dashboard at the end of the presentation. I want to get through all the content first. So it's a good time for a break. So let's continue. So let's review some of the technical details when it comes to experimentation configuration here at Mercari. You can read these details later. I just want to point out a few things. You'll often want to target newer app versions or even backend release versions for whatever reason. Maybe you have a rolling deployment, rolling deployment, and you only want to apply the configuration change to a newer version, even to a backend service. We have had many issues in the past where, as people are targeting newer client versions, they incorrectly put in the wrong version number into their configuration, and then the configuration suddenly activates, for example, on an older version, and undefined behavior starts happening. So if you are configuring an experiment or a feature flag, be very careful with which versions you're targeting. We have several parameters to adjust how the treatments are randomized against the population. Some of these parameters do affect the balance in the current V1 API or assignments in the current V1 API. So, for example, you don't want, when you run an experiment, you don't want users that are getting treatment A to magically shift to treatment B in the middle of your experiment, because they would be exposed to both experiences, or they might get a flip flop in their user experience, which is just bad in general. And so, for that reason, the weights should always remain fixed after your experiment starts. It's not something you can easily change later. If you only have a feature flag, then this might be okay. But you can freely adjust the threshold. For example, you can use threshold to do like a gradual rollout to make sure that everything is okay before ramping up your experiment. Also, the start and end date put a limit on the duration of your experiment. This sounds quite obvious on the face of it, but we have made many mistakes here as well. We'll actually be releasing a change to make this less error prone in the future. The key to note here is that you often do not want to set an end date, or if you do want to set one, it should be very far in the future. Normally, when we run an experiment, we don't want users to magically have their features turned off after the experiment duration. It just causes confusion and inconsistent user experience behavior. So this is something to also think about. What is the experience as you're implementing like a new feature or treatment for an experiment? What should the experience be for the user as the experimentation period ends? Most likely, the user should continue to receive the same treatment. But this also depends on the cases and what your team's plans are. So this is just a raw example of what our API actually looks like in reality. It's very basic. You just ask for the experiments, and then you get back. Each client gets back a list of variants that should be assigned. Um, so how does the assignment algorithm or randomization algorithm work? Well, there are a few headers that it looks at to basically target the experiment. One obvious one is the platform. This could be something like iOS, Android. And then the app version, which, as I mentioned earlier, will give us the information to target on the app version. We actually also have a Max version now, in addition to this, that's slightly outdated. And there are actually plans to increase our ability to target here. One common question that gets asked a lot is how does what happens if the user is not like assigned to the experiment via any of these targeting rules? What will they be assigned? Well, they get nothing. So this is very important because if your client code or even your server code, backend code, does not respond correctly to this behavior, so it expects a variant to be assigned, then you will lead to undefined behavior, which often means an incident or a crash. So you should always the clients, well, any code base should always handle the default case, which is no value. So I think we already talked about this. Yeah. So later we'll do a hands-on on how implementing this. So we'll get more into that. This looks outdated. I will skip this. Oh wait, no, it's not outdated. Okay, so let's review a very basic implementation of consuming experiment treatments with like a fictitious code base. So none of this is like real code, but the code is here just as a demonstration of what you might come across. And you may not. This is written in Go. You may not be a Go programmer, but I purposely made it simple to understand, so it just has basic if statements and function calls. So one key issue with this code base is that, well, there are several key issues. So here I'm showing you one potential issue, which is we have a call to the API to get the experiments for experiments 1, 2, and 3. And then we're going to consume the assignment for experiment 2. And we're going to pass that to our, in this case, a tutorial that's going to show this variant. So the question here is there something wrong with this code? And if there is, what is it? Room's pretty silent. Maybe you're all thinking. I'll give you 30 seconds. And I'll give you a hint. So how get experiments works is it makes a call to a server. We have panic if there's no variant for experiment 2. This actually won't happen in Go if you know Go, but this is the case in other programming languages. So you'll get a default value because the return type for get experiments, I believe, is an integer. So it'll default to 0. So you won't get a panic necessarily. So this applies to any code. So it can be iOS, it can be Android, Java, Swift, Python, doesn't matter. And the key hint is that get experiments performs a network call. So network down. Now we're getting closer. So this is the issue: is that what if our API or backend is down? What should happen? How should your client interpret that? And by client, I don't just mean like client apps, but also microservices, like search services, and running in our backend in the data center. There is a chance that network calls will not return ever, and your consuming code must be able to continue to operate as much as possible, regardless. So we don't want Mercari to stop working just because experimentation assignment is not working. It's like we literally have people going to convenience stores to ship their items, and and they need to open the app to like get their shipping labels. So just because they're not in an experiment doesn't mean they shouldn't get their shipping label. Is another way to think about it. Similarly, certain backend services are more important than others. So experimentation is not classified as a critical service. So if your service starts crashing, it'll lead to cascading events in the backend, and this causes major issues. So something to watch out for as you're implementing experiments or treatments for experiments. Okay. Now we get into get experiments. What get experiments does. This is how it currently works. It does an HTTP call. So I'll walk you through it. It tries 10 times to get a value from the server, and otherwise it just gives up. And there's another issue with this implementation, and it's not related to the one. It's not the same as the one we just discussed. So I'll give you 30 seconds to take a guess on what it could be. No ideas. My code is perfect. I don't write bugs. That is certainly not true. So I'll give you the answer. So there's no backoff algorithm implemented here. So this loop just tries to do a HTTP GET request, and if it fails, it just tries again over and over again. And it doesn't wait at all. So when we have a network system, a complicated network system, if this is what we do, even within our own backend, and let's assume that any service is down for even like say minutes, what are these consuming services going to do if the code was written like this? They're going to basically spam the endpoints when they come back up. And this is basically like our own clients DDoSing our own service. So the key point here is anytime you have a network call with a retry, there should be a back-off implementation. And it's very easy to overlook this. Now we get to the actual code that consumes the treatment. So obviously, anytime you consume a treatment, you want to have different variations of how the user experience will change. In this case, let's assume we're showing a tutorial page. This can apply to anything. It can be like selecting a search algorithm. It can be selecting some new like listing like pathway in the back end. But for this point, let's just make it simple. We're going to show different tutorials based off of which variant we get. So we have a slideshow, animation, or demo video as the options. And at the very beginning, so even before we show anything to the user, we're going to log the event that this user for experiment 2 received whatever variant they received. The question here is this logging correct? And I'll give you a 50-50 chance. You can say yes or no. So you have a 50% chance of getting it right. So I encourage you to guess. Yes, I like the confidence. You have yes and no. Ten more seconds. I mean, if you don't answer, it's an automatic like 0 points kind of situation. So you might as well guess. We have some we have some negotiation happening. Yes. We have a good distribution. We have a good randomized distribution going on. No seems to be winning. Okay, last calls. Seems like half of you are willing to not even try to get the right answer. So we have no. I think it should happen when the variance effect go into place. This is the best answer. Oops, I did not have an explanation for us, an explanation slide. So Augustine wins. He has the right answer. So when should we log that a user experienced some treatment? It's when the user actually experienced the treatment. And according to this code, we don't know what's going to happen when this slideshow function is called. We don't know what's going to happen when animation is called. So all of these are black boxes you can imagine. So this code is very simple, and the idea is very simple. It's very like, well, yeah, that's obvious. I'm never going to do that. But now imagine you're in a complicated system where you have an experience that's tied to both the backend components and the front end components. So, like, let's take a very basic example. You have a selection of which search algorithm to choose. There's a better search algorithm, and there's a worse one, but you don't know which one is going to perform better. So you're going to randomly distribute this to all the users. Well, hopefully not all the users, but a good portion of the users, and see how they perform in, like, let's say, click-through rate. Well, if your backend just logs it, that it responded to the user, and I don't know, the user goes into a tunnel because they're on the Shinkansen, and they don't actually get the response, does that actually count as a logged event? did the user actually experience the search results? That's something to keep in mind. I think that it is not a bad place for the log, but you also should have more logs inside the functions. Yeah, so this is something we have to think about, which is that um, often we see teams making the simple mistake, which is that we log something, we think we're logging something, and then when we go to do the analysis, we find that the log quality is not quite there. So we cannot actually have an actual analysis of whether our hypothesis is proven or disproven because the logs don't suggest it. And this is actually a big pity because you'll have spent probably a few months of time to get this point and realize that you have to run it over again because of something simple like log quality. So everything could be perfect, your experiment design, your implementation of the features and treatments, but then your logging is incorrect and now you don't know what to do. So be very careful where you log. Okay, here's a summary of what we just reviewed. So any network, be careful when you have network requests. Notably, you need to retry and you need to have back off. So many of the libraries you may encounter already have this, but often you might be pressured into implementing a feature or in a place where it may not be convenient to use the pre-built functionality, and you should be aware of what's really happening under the hood. This is just a basic thing, but it's a reminder, responding correctly to how the server responds to your requests. So sometimes the server might be unavailable and it might be a simple 500 error, but it could be something more nuanced. We currently don't have these very diversified HTTP codes, at least for the experimentation API, but you never know. Also, be very careful with how you log events. So if you don't want to think too hard, backend services should log after the response is completed, and front-end clients should log whenever the user actually can see the component or treatment. Okay, so these are some of the shortcomings in our current widely available system, and this is we're considering it already a legacy system, but we have to keep using it until we completely transition. So this is just a heads up on what to look out for. We don't have an easy way of re-randomizing. So when we run experiments, we should actually run what's called an AA test before the AB test. I mean, who here is familiar with AA testing? You can just raise your hand. No one. So AA testing is actually running, configuring everything for the randomized trial, but actually not giving any treatment. So any ideas why we would do this? Why we would run, set up everything, but not actually give users a different treatment? No thoughts. So one of the key things when it comes to randomization, we assume random is uniform. Like you flip a coin and you'll get like heads 50 times. Out of 100 times of flipping a coin, you'll get heads 50 times and you'll get tails 50 times. But when it comes to randomization in our experimentation system, well, even given a truly uniform distribution or truly random function, you may not actually get a good distribution. So there's a chance that you might get like a 51 to 49% split, for example, given a two treatment system. And this is actually not a good thing because it will invalidate a lot of the effects you're trying to measure when it comes to statistical analysis. So we run the AA test to check for this balance and to see if the groups truly are showing the same behavior. So you may see that one group might have like a power seller, and this power seller is kind of an outlier, and they will greatly increase the sell-through rate unintentionally. Meanwhile, the other group doesn't have the same number of power sellers, and so if you did not actually run the AA test, you would not notice that. And this is an issue in our current system because you cannot easily re-randomize after the fact. We're in the process of fixing this, but it's something to note. So the other big one is that each experiment is running at the same time as all other experiments. So for example, let's say the listing team is trying out some new listing features. Meanwhile, the search team is running some experiments on like search results or the search page. This means that you will have all combinations of all experiments at the same time. So for the basic case where you don't care really, you want the full population to be exposed, and this is fine, but occasionally you will have an experiment design. Your PM might suggest some kind of experiment design that depends on certain users being isolated from other experiences that are happening. This we cannot do yet. And the keyword is yet. Last one, cannot configure multiple client parameters from a single experiment. We're also working on this one. This one isn't such a big deal now because you can work around this by just having more code in the treatment assignment, the consuming code for the treatments. So, like what does this entail? So like, let's say you're testing button color, changing the colors for a button and the text. So you have different combinations of text and button color. Right now, our system only has an integer variant. And so in order to do this, you would have to enumerate all possible combinations as, say, integers of 1 through 4, if there are two options for each parameter. In the future, we'll make this easier for you. This is a preview about what's coming in the future. So as mentioned, you'll be able to have multiple parameter values selection. So being able to separate button color versus button text, for example. We're going to shift from this idea of variant to this concept of treatment, which is more in line with the actual experimentation terminology. And the only difference here is that treatment is a set of parameter values. We'll have a much better bucketing algorithm or randomization algorithm, and a lot more. So how will things change? This is just a preview, so this is not set in stone, but instead of receiving an integer value, we'll be able to receive, let's say, a string value. And this string value can actually be defined in the configuration. And as you can imagine, this would make reconfiguring experiments much easier. In fact, maybe it would make it, if we did everything correctly, we would be able to make our client, we would be able to set up experiments on our clients without actually having to redeploy new clients. That would be very powerful. Okay, now on to general experimentation issues. Sorry for a lot of text. It was just really hard to come up with nice charts for this. So one key issue in experimentation is something called Twyman's law. And Twyman's law basically states that anytime you observe some effect, so you measure something, like let's say you're measuring sell-through rate, so how much sellers are able to actually sell items when a buyer's interested. And you notice a really large increase in like sell-through rate from launching your experiment. Twyman's law states that this is most likely not due to your actual experiment. There's probably some other key factor, often in these systems, often some issue that is causing this. It's not a direct effect of whatever you changed. And you need to actually go back and investigate why that is. So I don't know of any experiments that we've experienced that have been subject to Twyman's law, but it's something to note. So in your teams, keep this in mind. Accurate logging is another possible problem. We talked about briefly about this, so I'm not going to talk about it much here. So randomization is also a problem. And our current V1 system relies on MD5, and actually the future one will rely on MD5 as well, but in a different way. And MD5 was not, it's a hashing algorithm, and one of the design goals was for good randomization, like equal distribution. But even given that, there has been one instance here at Mercari where there was obvious randomization imbalance between like assignment, like populations, simply because of MD5. So we couldn't find any issue with like any of the implementation of the source code, or the clients, or the design of the experiment. Yet we noticed that one variant was receiving more users than anticipated. So again, another good reason to check AA test. And even if MD5 was perfect and you truly did have random results, there's still a chance, just due to probability, that your buckets won't hit a good distribution, equal distribution. Another common issue is confounding variables. So this is maybe one of the hardest things to deal with in experimentation, is how do you control for confounding variables? And Mercari is no different. In fact, in some ways it's worse because of a two-sided marketplace. But even on a technical level, there are confounding variables. Like suppose you implement a new service, a new query, and this database query is noticeably slower than the one it's replacing. Um, and you run an experiment to see if this new query, which I don't know, supposedly returns better results, search results, for example. It could be anything though. Seems to be showing poor performance. Is that due to the algorithm, or is it just because it's slow? Um, if we're not careful to actually check for these things, so in this case, the response time of our algorithm, we could actually unintentionally be measuring the confounding variable, such as how slow our API is. So the negative performance of this algorithm might be due to its performance in terms of latency, not its performance in terms of quality. Another one to look at is external factors like day of week, seasonality. Mercari is very affected by seasonality. So running an experiment during the summer is not the same as running it during the winter, where certain items sell more often than other items. Another thing to keep in mind. Another hard one, Sattva. This is stable unit treatment value assumption. Why am I going to tell you about this one? It's because we operate in a two-sided marketplace, and we have experienced teams that wanted to do experiments that are affected by both sides of the market. So you have a buyer and you have a seller. This is a two-sided marketplace, and there are network effects. So, for example, let's say a team wants to have a new feature for listers or sellers that will have this negotiation feature. So certain sellers will get the negotiation feature and certain sellers will not get this negotiation feature. How does that affect buyers? Well, the buyers will randomly go to both kinds of seller. And it's likely that each buyer will experience both types of sellers. So in this case, we cannot measure the performance of our negotiation feature because the experience is just changing for each buyer. The buyer is not having a stable experience when it comes to purchasing an item. And this is actually very hard to control for in a two-sided marketplace. There are ways, but I'll leave that as a thought process. Okay, that's the end of experimentation. So now let's briefly talk about feature flags. So why do we use feature flags? I mean, these are the bullet points, but and they seem quite obvious at a glance, but let's get into it. So tangibly, what's really happening? In any kind of large team development, you're going to have many developers committing to the same code base and putting changes onto the same branch. So in this case, we have you working on your branch happily, and then we have a team member, Alice, or even not a non-team member. It could be another team that's also working on the same code base, and they're working on their commits. And Alice manages to get her change in before you do, and your feature is quite large, so you need a lot of time to work on it. And so several commits into the future, maybe even tens of commits into the future, you want to finally merge your change in and notice that you're really far behind. And there are so many conflicts in your change. By the way, you only have like a few more days to complete it because your team was planning to release your feature next week. What do you do? So here's the goal. This is not the solution yet, but here's the goal. Obviously, you want to get your change in before Alice gets her changes in. In fact, you want to be able to merge as soon as you possibly can. So here's one idea of how to solve this. We commonly use Git source control. And one feature in Git is called rebasing. So you can take any change and rebase it on top of another branch. And you can regularly do this to pick up the changes as much as you'd like. So let's say every day before you start working, you rebase to whatever is on the main branch and pick up all those changes. So obviously, the good thing is that you're up to date and you won't have that many conflicts when you do actually want to merge. But now you have this regular routine task of merging your branch, or not merging, rebasing your branch routinely. That's a lot of busy work. Here's another idea. And actually, I have to say that many of these ideas were tried, and some teams actually still apply this. So these are not far from reality. So another idea is to have separate branches. So we're going to have a dev branch and a release branch, and the release branch will only contain the stuff that's released, and dev will have all of the unstable changes that are going in at the same time, and everyone just tries to merge into dev as fast as they possibly can. And often at the cost of like bugs and maybe incompatible changes, maybe even the code doesn't build in the cases where our CI pipeline is not fully configured. The problem here is that when we actually want to release, someone has to figure out if the dev branch is worthy of releasing. And that is a lot of work. So neither of these solutions are ideal. In both solutions, we're pushing the effort towards our control source control system. But we still have the same goal. We still need to release, we still need to merge as fast as possible. And ideally, we should be able to release the code base at any commit at any time. So what's the solution? Well, just merge immediately. And there's obvious questions about that. So here's another question for you. Here's our code base. Very simple. We have an old feature and a new feature. And the goal is to have both in the same code base. How can we do it? Feature flag. Yeah. More specifically, like give me some code. On off. How would you implement on off? Environment variable. Here, environment variable. Can it be? It can be any language you want. Any language feature. I don't care. Use maps. You can use. You can use any library you want. Don't write too much code. Just I'll give you give the confident ones 10 more seconds. Inject feature as dependency. Yeah, that's another option. Okay, so lots of ideas. I like that. Here's a very simple idea. I mean, it was mentioned already, the feature toggle. And this is a very basic feature toggle implementation. So you don't actually delete anything, you just add a toggle. And now your program can actually continue to use the old code path, even though you've been adding your code into the new code path. In fact, this is complete. There's no dependency on a library. There's no dependency on an external API call, network call, configuration file. It's all here. So this is something to keep in mind. We use this kind of code a lot. So there's a comment. We use this kind of code a lot in my previous team, but you need to remind to remove it later or it'll be there forever. Yes, this is a problem, and we will get to that. So to complete the slides, feature toggle feature flag hide code paths. And this is what allows us to merge code immediately. And if you want to know more, this is called trunk-based development. This is the process. So we'll return to that as part of the hands-on. So for all of you still thinking, that's great, and I want you to keep thinking, but let me finish the content. So now testing in production briefly. If we combine feature flags with our experiment API, we gain the ability to remotely activate and deactivate any code path and therefore feature. And this allows us to do testing in production. But why do it? Any thoughts? Why test on production users with live code, live backend, live clients? Give you a minute to suggest something. I'll take any answer. Real world results. Yeah, that's a good idea. We can see what really happens. Still, there's a question like, you're testing in production. Won't you affect real people? Do you want to take that risk? Last chance for other ideas. Be safe and deploy some feature with external APIs. Can you be more specific? Why would you be safe? Not relying on fake smocks. Well, we would hope that we can catch that in the QA phase, or even before release. If you depend on an external API, you can use it to turn on and turn off if we have some issue. Close. So first, for some background, here's the basic life cycle. You do a new feature, and then maybe you have QA tested a bit, and then you release whatever that feature is. And QA is very slow and expensive. So how does it change if we test in production? Well, we do the new feature development. Of course, we still do some QA. And then we release with the feature disabled. Now we get to the actual testing and production part. We don't turn it on for everyone. We turn it on for a very small percentage of the users. And like one of you suggested, because our app is configurable, we can actually revert this change easily. So we monitor this 1% rollout and see if everything is still okay. And if everything is okay, then we continue. Otherwise, we roll it back. And this gets around a lot of issues, like, for example, getting updated versions of or hotfix versions of the app redeployed to, for example, iOS devices and Android devices is very slow and lengthy. And if you can just tell the app to stop activating the feature, that is near as close to real time as we can get. So we do it to limit the exposure of our risk. And that's the end of feature flag. So we try to aim for trunk-based development to get our code changes merged as soon as possible by hiding them behind feature toggles. We currently reuse our existing Experiments API to do this. It's a little bit hacky, but it works. In the future, we will continue to do this, but in a different way. So there will be more distinction in the future between feature flag and experiment in the future. And why? One reason why we do this is to enable testing in production, which, contrary to what it sounds like, actually allows us to reduce the risk of rolling out new features.